Hi again, I'm James from Enterprise IoT Insights. I'm joined at the Things Conference by Carsten Brinkschulte from DRYAD Networks. Carsten, lovely to have you with us.
Hi, lovely to see you.
And Carsten, give me, if you like, the elevator pitch. Tell me, I guess, firstly, why you're doing this. Say something of the carbon monoxide savings, the issue at hand. Why is this so important?
Well, I mean, climate change, I guess, is the biggest problem that we're facing as humanity at the moment. And wildfires are a big problem that we see in the news all day. But what most people don't know is that they're causing up to 20% of global CO2 emissions. It's between 6 and 8 billion tons of CO2 being emitted out of those fires. It's about the same amount the entire traffic puts into the air. All cars, all aeroplanes, all ships combined emit about the same amount. Yet we put a lot of effort into electrification of traffic and power generation and industry, but 20% of the problem is coming from fires, and we need to put the right attention to that problem.
Okay, and talk about the solution. You've got it here. Let's look at that. How it works. What you're doing. You're using LoRaWAN. You're using a kind of meshed network version of that. Explain the tech part, if you can.
Sure. DRYAD has developed an end-to-end solution that has 4 components. The first component is a solar-powered gas sensor that can actually detect the fire during the smoldering phase. It's solar-powered, doesn't use any batteries. It stores energy in supercapacitors for the night. It does work in the shade of the trees, and it has a gas sensing chip, a Bosch BME 688, that can detect hydrogen, carbon monoxide, and volatile organic compounds. It basically is like an electronic nose. It can smell the fire. And when it can smell a fire, that means it can detect the fire during the smoldering phase, when it starts, before it spreads out of control. And that is a key advantage to the firefighters, right? They want to know before fire really gets out of control and not when it's already a football pitch on fire. So that's where we are positioning. We want to do ultra early detection of fires with this IoT sensor. And of course, being at this conference, Things Conference, it's a LoRaWAN device. So this is a Class A device that sends LoRaWAN messages when it detects a fire. We also send temperature, humidity, air pressure every 2 hours. And the second component is a mesh network. So because we need to communicate in the forest, it's really difficult. There are lots of trees with water and everything. So we're building a solar-powered mesh gateways. They're a bit bigger, so I couldn't bring them here. But they're solar-powered, they hang them on a tree, and they do a communications bubble of about 2 kilometers range in a mesh network, eventually hitting what we call a border gateway, which has a 4G LTE connection and satellite fallback with Swarm. And then we can actually relay into the internet, where we have a cloud platform for device management and alerting. So it's an end-to-end solution. Sensors, meshed gateways, key for the forest, and then the cloud platform for alert management.
And how many of the sensors do you need to cover a forest? How does it map out?
Well, the more the better. The more sensors you put, the faster we can detect. We think a good price-performance ratio is at about 1 per hectare, which is 100 by 100 meters, to put one sensor. And we're focused on the human-induced fires, which are 85 to 80% of the fires being started. So we are responsible for the fires with arson, with recklessness, with accidents, and those are the fires we want to focus on. So wherever there's human activity in the forest, we want to put a sensor around roads, pathways, camping sites. That's where we want to put a sensor every 100 meter.
And is there some training of the algorithm or something like that to eliminate kind of false positives, this kind of stuff, or is it pretty well honed already? Just give us a sense of that.
Well, there was a key challenge that we had to solve. We're using built-in machine learning in the sensor to train the sensor for the specific smell of a forest. So you have to fine-tune it for the smell of the natural forest, but also when it burns. So a eucalyptus tree smells differently than an oak tree on fire. So we train the machine learning model, execute it actually in the device specifically, and then we do over-the-air firmware update to update the model in the device, which was a big challenge, but we did solve that. So yes, it needs to be updated and tuned for every forest.
Okay. And Carsten, it sounds amazing. It sounds fantastic. It sounds like it should be it should be well deployed already. Just give us a sense of how that is going, momentum pickup, when proofs of concept, this kind of stuff.
Well, we've been working on this for 2 years. We've just introduced the product a few months ago. We now have 12 installations with customers in Southern Europe, in Greece, in Spain, in Portugal, but also in the United States and Turkey and in South Korea. And those 12 installations, I think, are going quite well. We're doing small-scale installations now to prove the concept. And next month, we're going to manufacture 10,000 units to then go to pilot phase with these customers with a few hundred sensors. Next year, we have ordered 230,000 units to actually go really live and large scale. And then that's 2023 when we will start to detect real fires.
Okay. And just a word on this event. We're here today. It's a LoRaWAN event. The ecosystem is here. The developer ecosystem is here. How are you finding it? Why LoRaWAN? Why are you using LoRaWAN and not, NB-IoT with a cellular backhaul? This kind of stuff.
Well, we looked at all of the technical solutions out there, and narrowband IoT simply does not work in the forest, in the depth of the forest. And LoRaWAN was the only solution available that we can deploy private networks, and they can go long range, low cost in the unlicensed band. So LoRaWAN was the only choice, literally. We just added mesh on top of it so that we can go large scale. It's a brilliant technology and a thriving ecosystem, and we're looking forward to bring more sensors, soil moisture, and other sensors from third parties into our network.
And Carsten, I kind of met you briefly at the LoRaWAN event in Paris in the summer. You're here. It seems you are kind of doing the tour, as it were. How are you finding this event? How does it compare, say, with other events you've attended?
Well, it's great to have people that are all centered around the ecosystem, of course, right? These are all friends and families, so to say. And it's good to see that this is a thriving event. So you can see lots of solutions, everybody building great products, and they all seemingly work together. So it really feels good to be part of that community. And I think the momentum is there. LoRaWAN is here to stay and scale.
Carsten, thank you very much for your time. It's been great. Appreciate it.